So here is yet another problem from JEE Advanced 2017. The problem says O is the origin and PQR is a triangle. The point S is such that there is a relationship which is given between the position vectors corresponding to the points P, Q and R and this point S. The question asks, what is this point S when you consider the triangle PQR? So there are these distinguished points which we can relate to every triangle, that is the centroid, the orthocenter, the incenter and the circumcenter, and we need to choose one among them. Okay, so although there is this kind of a relationship, it's very difficult to figure out what exactly it is, but a good step forward would be to replace these OP, OQ and all with small letters P, Q and R by assuming that P, Q and R correspond to the position vectors. So that itself will give a lot of clarity to the problem. So we get the relationship as P dot Q. Let us first write down what is the first equation. So it says that P dot Q plus R dot S is equal to R dot P plus Q dot S. Okay. Now this relationship as such doesn't give any information, but maybe after some kind of juggling we can try to get hold of some kind of a relationship. So let's see what can be done. So one thing, there is this common factors which are involved over here. So if we shift so there is Q which is common here in this term and in this term. So let us write that as Q dot, so I bring it to the LHS, I get it as P minus S. And over here, so here let us see what is there. Then there is R which is common in these two terms, and therefore I can write it as, so I have brought it here Q dot, yeah, so I bring it as R dot and this becomes S minus P, right, S minus P. Okay, now you have a look here, we have R dot S minus P and we have Q dot P minus S, which means, so this is equal to 0, which means we can actually write it in a better way. That is, we can write it as R minus Q dot S minus P, S minus P equals 0. Okay, just simple algebra, vector algebra. Okay, now it makes lot of sense because R minus Q, what is this? If you subtract the position vectors, it just says that the vector QR is, and if you take its dot product with the vector PS, this is equal to 0. Okay, now have a look at what does this particular thing say. That is, if you have a triangle which has got its vertices as P, Q and R, now it says that S is a point such that somewhere over here, that is, if you join PS, this vector is perpendicular to this side QR. So which means that we are already getting a clue that PS is an altitude to the side QR. Okay, so this already gives us a lot of information, and in fact in such a case you can very well conclude that the point that we are looking at is nothing but the point of concurrence of the altitudes, which is the orthocenter. Okay, but you can very well go one step ahead and take the other equation, and over there you will get the another kind of a relationship. That is, if you join, that is, if you take another side, that is, say for example PR, then you will get the equation as RP. If you take its dot product with QS, you will get it is equal to 0. That this equation you will get if you take this is equal to this. Okay, so just a matter of things. So which implies that S is the point of concurrence of the altitudes, that is the orthocenter. Okay, so here was a very a simple problem, just that you had to figure out what exactly is the relationship, the geometrical relationship, using some simple nice algebra.